Welcome to Study Loop.
Now we're told to consider that there's friction acting on the ramp here in the previous problem. So we now have a coefficient of friction of 0.2, coefficient of kinetic friction. So we basically, what we have is some energy that's dissipated by that friction as this package slides down here. And we can figure out what that energy is because the friction force is constant. So we can integrate the work over that constant force over the distance that the force acts. So the work then that the friction force does, or the energy that it dissipates, is the mu times the normal force times over the distance over which it acts. The normal force is mg cosine theta, because it doesn't counteract the entire weight because some of the weight is causing the package to slide. So just the normal force is mg cosine theta. And so now what we have is we have the initial energy minus the work done by friction equals the final energy. And again, we know everything in this equation except for delta L, and we can figure out that delta L is now 0.174 meters. And it makes sense that that should be less than this because we've dissipated some of the energy as heat as the package slides down this ramp. Some of the energy is going off at heat, so we're not going to compress the spring as much